All right, Trig, Chapter 5, Section 1, Trigonometry Identities on this section. You are going to need to memorize that the quotient identities are that the tangent of theta would equal sine theta over cosine theta, and that the cotangent theta would be its reciprocal, which would be cosine theta over sine theta. This is going to be very useful throughout this entire chapter. So again, that's called the quotient identities. The tangent of theta is sine over cosine. Cotangent is cosine over sine. This is in your Quizlet. We will be back to taking Quizlet test every day when we walk into class, a little mini 10-question multiple choice Quizlet. And therefore we will have a Quizlet test at the end of this chapter. So the proof of the Pythagorean identities. We're going to start with, we have a right triangle in the first quadrant. X is the distance across here. Y is your vertical distance. Theta is this angle, and R is the length of the hypotenuse. If I was to do Pythagorean theorem, that would give me x squared plus y squared equals r squared, which everybody knows to be true. If I talk to you about the cosine of theta, the cosine of theta would be the adjacent leg x over the hypotenuse of r. The sine of theta would be the opposite leg y over the hypotenuse of r. If I go ahead and solve this first equation here for x, that would give me x equals r times cosine theta. And I'm going to solve this one for y, so y would equal r times the sine of theta. I'm going to square both of those, since up in the first equation I had x squared plus y squared. So I want to take x squared here. So if I square both sides of this, I get x squared equals r squared cosine squared theta. I square both sides of the y, so therefore y squared equals r squared sine squared theta. We're now going to substitute. I'm going to take and substitute this r squared cosine squared theta for the x squared. And I'm going to substitute r squared sine squared for the y squared. In doing so, I can now factor out r squared out of both equations. And when I factor out r squared and divide both sides by r squared, I end up with r squared divided by r squared is 1. And that gives me cosine squared plus sine squared. And that is your first Pythagorean identity. And like I said, these will need to be memorized. There's two more Pythagorean identities that are based off of this one. Let's say I divide each of these terms by cosine squared. Well, cosine squared divided by cosine squared would be 1. Sine squared divided by cosine squared, sine over cosine's tangent, so that'd be tangent squared. 1 over cosine squared, the reciprocal of that would be the secant squared. Instead of dividing all three of those by the cosine squared, this time if I divide by sine squared, cosine over sine is equivalent to cotangent. So cosine squared over sine squared is cotangent squared. Sine squared divided by sine squared is 1. 1 divided by sine squared, 1 over sine is the reciprocal of the cosecant, and that's where I got the cosecant squared of theta there. And again, all three of those in those boxes are on your Quizlet. They're in all kinds of different forms. Like I might ask you, what is 1 minus sine squared equal to on Quizlet? That would be equal to cosine squared. I might ask you, what does secant squared minus 1 equal? Well, secant squared minus 1 would be equal to tangent squared. Or I might ask you, what is cotangent squared minus cosecant squared? Well, that would be equal to negative 1. So I could use these three in any forms and mix and match them all up, where you can have a 1, a negative 1, or even one of the trig functions as your answer. So again, please make sure you do log into Quizlet and you do start studying these for the Pythagorean identities. So at this point, we should have memorized the 3 Pythagorean identities, the 3 reciprocal identities, these 2 new quotient identities, and then the negative angle identities. And again, please work on memorizing these. This will be a necessity in this chapter. So example 1. If the cosine of theta is given to us as 5/8 and theta is told to be in quadrant 4, we're supposed to find each value. So in quadrant 4, here's the picture of the angle, down to here, quadrant 4, my x would be positive and my y would be negative. So I prefer to go ahead and say, well, cosine, that was x over r, so the x is 5, my r is 8. Then Pythagorean theorem, I need 64 minus 25, and then the square root of that difference, so square root of 39 for this y. Now it was negative because it was going down. Now when I want the sine of theta, all I need to do is y over r, and I have my answer, so negative square root of 39 over 8. Now if you hit the view an example with your book, it's going to go through a little bit longer process, and I'll talk about that in a minute. The tangent of theta, remember, is y over x, so therefore y over x, and that would be finished. The secant of negative theta, well, the secant is the reciprocal of the cosine, so that would be 1 over the cosine of negative theta. Oh, never mind. I went over back to A. All right. So from the Pythagorean identity, this is the view and example from the book, the way the book would teach it. Sine squared plus cosine squared is 1. They then solve for sine here. We know cosine is 5/8. So we plug in our 5/8, we square that. That would be 25/64. You take 25/64 away from 1. After doing that, then you take plus or minus the square root of that. Well, then you'd have to figure out, is your answer supposed to be positive or negative? But again, because it's in quadrant 4, all students take calculus. The cosine would probably be positive here. That means the sine would be negative, and you go right back to this answer. To me, that's a lot longer way to do it, a little bit more difficult, but some of you might prefer that method. Maybe you understand it better. The tangent of theta is the sine over the cosine. So a lot of times they're going to show that one with sine over cosine. So you would take this sine answer and divide it by this cosine answer. Don't forget, dividing fractions easy as pie. Flip that second and multiply. The 8s would reduce then. So you'd still end up with the negative square root of 39 over 5. These 8s right here would reduce. All right, secant's the reciprocal of cosine. So I rewrote it as the reciprocal identity first. Now, the cosine of negative theta, if I went positive 30 degrees or negative 30 degrees, the cosine in both situations would still be positive. So whether I say the cosine of theta or the cosine of negative theta, they would be equal. They're equivalent to each other. So all I'm asking you for here is basically the reciprocal of the cosine. Now remember, the cosine of theta was 5/8, so I want that reciprocal of that, so this answer would be 8/5. So this one here, example 2, express the tangent of theta in terms of only a cosine of theta. Now we know the sine of theta is equal to sine over cosine. Now they're telling me in my directions I cannot have the word cosine in the answer. So far I have a cosine in it, but I cannot have the word sine. Now what I do know is cosine squared plus sine squared equals 1. So what if I was to solve this for the sine using the square root property? In other words, I would have to take 1 minus the cosine squared and then take plus or minus that square root. I'm going to substitute that right there for the word sine, and there's my answer in terms of cosine of thetas only. The directions say write the secant of theta plus cosecant of theta in terms of sine and cosine, and then simplify the expression. So my first step is to rewrite it in terms of sine or cosine. The secant's the reciprocal of cosine, cosecant's the reciprocal of sine. So I go ahead and I rewrote it. Now to simplify, that means they want me to get a common denominator and combine like terms. So I get a common denominator. The first fraction needs to be multiplied by sine. The second fraction needs to be multiplied by cosine of theta on top and bottom. So I've rewritten it. Now the numerator would be sine theta plus cosine theta, when the denominator would be sine theta cosine theta. And that would be finished. So this one here would be like a multiple choice answer. Now it could have more than one choice. They said to choose the correct expression. So if the problem is 1 minus the cotangent squared, does it equal, which of these does it equal? Maybe A and B. So in other words, it doesn't have to be just one of them. So this is what we need to figure out. Now remember our Pythagorean identities. Now this has a cotangent squared, so I do want to start there. Here's my cotangent squared. If I look at what cotangent squared equals, doesn't cotangent squared equal cosecant squared minus 1? So I think that's what I would want to start with. So again, I just said that, so this problem here I had 1 minus the cotangent squared. 1 minus cotangent squared. Well, 1, right here, I could do it this way. 1 equals cosine squared plus sine squared. So I could have cosine squared plus sine squared minus cotangent squared. I don't see that as any of the choices. Right? 1 minus cotangent squared. So again, back to 1 being cosine squared plus sine squared. Or on the second one, 1 equals secant squared minus tangent squared. For this line, do I see a secant squared? Yep. Minus tangent squared, minus cotangent squared. So F looks good. If I try this third one down here, 1 would equal, coming back up to the third Pythagorean identity, it would equal cosecant squared minus cotangent squared. That's in place of 1. Now do I have that as an answer? Cosecant squared minus 2 cotangent squared. No, I do not have any of these have minus 2 cotangent squared. But what I did have was this line existed right here at F. So write the expression in terms of sine and cosines only, and then simplify so that no quotient appears in the final answer. That means they want no denominator, no fraction. So this already is a 1. This is cosine. We're good. Secant, though, would be the reciprocal of cosine. So my first step, they told me to rewrite it in terms of sine or cosine. So that's what I'm going to do. I now can FOIL out or box this out, whichever you prefer to do. So if I take 1 times 1, that gives me the 1. 1 times this one here, so 1 over cosine or theta, sorry, with the negative. Cosine theta times 1, there's cosine theta. Cosine theta times this fraction, see the cosines would reduce, that would give me a negative 1 there. Now notice 1 minus 1 would be gone. I'm supposed to write my answer with no quotients, that means no fractions. Well, 1 over cosine is equivalent to the secant of theta, so therefore that would be negative secant theta plus cosine theta. And again, looking back at my directions, I started off with write it in terms of sine or cosine. I did. Simplify so that there's no quotients. That means there's no fractions in the problem. The next one had said cosecant alpha minus sine of alpha. So cosecant is 1 over the sine of alpha. Again, let's get a common denominator. So that means this right here was sine of alpha over 1. So this one needs to be multiplied on top and bottom by a sine of alpha. So I'll do that first. Now that I have a common denominator, that numerator becomes 1 minus sine squared of alpha. By your Pythagorean identities down here at the bottom, 1 minus sine squared, 1 minus sine squared would be equal to cosine squared. So that numerator is cosine squared alpha. Denominator is still sine of alpha. Now remember, we're supposed to rewrite this with no quotients. So if I bring the word sine up, the reciprocal identity, the reciprocal of sine is the cosecant. So I could rewrite this problem as, well, there's another option. So I could have also typed in the answer. Let me write that for you and should display it for you. I could have rewritten the answer as cosine squared alpha times the cosecant of alpha. So it could have also, it's not going to show up. There we go. It's still not showing up. Darn it. There we go. So you could have written that answer. It would have accepted that. Cosine squared times cosecant. Now, the way that I got the answer that is here, because it was multiple choice, if I take cosine over sine, that would be the cotangent, and then I still had that times a cosine. So whereas I could have broke this numerator up as cosine over sine times a cosine. So that's the cosine that was left over. A cosine over sine was cotangent. The way I originally was saying to do that, that's not on the screen, would have been to leave this cosecant squared on top and bring the sine up. Bringing that sine up would have made that then right there the cosecant of x, or the alpha. All right, write the expression in terms of sines and cosines again. Simplify so that there's no quotients, and the final expression are all functions are of theta only. All right, so for my identities, cosecant squared minus 1. Right here, if I had cosecant squared minus 1, that would equal cotangent squared. The denominator, if I had secant squared minus 1, well, secant squared minus 1 would have been tangent squared. So some of you might want to do it from that route. Some of you might want to rewrite it first. I personally would prefer to do it this way. Now remember, cotangent squared is the reciprocal of the tangent. Or I could say tangent was the reciprocal of the cotangent. So if I brought that tangent up, that would become another cotangent, and cotangent squared times cotangent squared is cotangent to the 4th. This problem, negative cosecant squared, 1 minus secant squared. If I had 1 minus the secant squared, move the secant squared over to the left, that would equal negative tangent squared. So this right here actually could become negative tangent squared. I'm not sure if that's what I did. I did. Now, tangent is the same thing as sine squared over cosine squared. So I rewrote it. Look at here what goes away. These reduce. Therefore, negative times negative, my answer is positive sine squared. That would be the end of your 5.1. I hope you realize the importance of memorizing your Pythagorean identities, your reciprocal identities, your quotient identities, and your negative angle identities. Please get working on the Quizlet every single night. Every day you need to do another 10-question Quizlet at home, and you need to do a 10-question Quizlet in class every single day. The sooner you get these memorized, the much easier that this chapter will become for you. At this time, I would like you to do your multiples of 3 and number 7. So when you come to class, if you have any questions, if you are unable to do those, then we know which ones I need to reteach to you to give you some help. Have a great day.